Hey, I'm Jesse Whiting from Ghostwire Audio, and I want to know how to make plugins, but I don't. So, welcome to day 2 of MicroDSP, where we learn digital signal processing using tiny little micro projects. Today's project is fairly simple, but pretty powerful, and it's an absolutely necessary foundation in learning how to manipulate audio. That being a gain processor. If you've ever used a volume knob in a plugin, this is exactly what's happening under the hood. The underlying idea here is we're going to take a wave file, read it sample by sample, multiply each sample by a certain number, that being your gain value, and then we're going to write it out to a new output file. And that's it. No libraries, no magic, just raw audio data. First, we're going to open the wave file you want to change in binary mode, because audio files aren't text, they're just bytes. So we need to read them exactly as they exist on disk. Then we're going to copy the first 44 bytes straight across. These bytes are the wave header. If you don't know what a wave header is, I will be making a video explaining it in the future, but for now I have a brief explanation in day 1, so I highly encourage you to go check that out. Now here, we're not even going to touch the wave header, because we're not changing the fundamental structure of the audio file, just the values of the data. Now here's where the actual processing happens. Each audio file is a signed 16-bit integer, meaning it ranges from about -32,000 to +32,000. In this case, we're going to use a while true loop and iterate through each audio sample. For each sample, we're going to multiply it by your choice of gain value, and the resulting sample will be amplified to that value. In the case of my project, which will be on GitHub, my gain value is set to 0.5, so the volume will half. But here's a pretty important catch. Once we do the math, the variable becomes a double, and can thus very easily go outside of that 16-bit range. And if we just cast it right back into that 16-bit range, some very bad things can happen. In that case, a lot of overflow would be introduced, and sounds would wrap around. Some samples could completely flip signs, causing a huge dip in the waveform, and those sharp dips or jumps can sound really bad. And so, we clamp. Clamping is a simple process in which if the value is too high, we snap it to the maximum value, and if it's too low, we snap it to the minimum. If it's within that range, we're obviously just not gonna touch it. This is basically hard clipping. Once the waveform reaches that ceiling, it just flattens out. Now, this is still distortion, but it's controlled distortion rather than random digital chaos. And every real audio system does this in some form, whether that be software, hardware, or an ADC hitting a voltage limit. Only after clamping do we convert the value back to a 16-bit range and write it to the output file. This exact flow, being converting to high precision, processing, clamping, and then converting back, is everywhere in DSP. Later on, we're going to replace the practice of hard clamping with softer techniques, so like saturation and soft clipping. But for now, this is a great guardrail for preventing your audio from completely falling apart. And yeah, that concludes day 2 of MicroDSP. I will catch y'all later, and stay wired.